Okay, so this is the continued discussion of assignment 4, multi-node trees for pyramid scheme. In the last video, we discussed this, assignment and also discussed what is the multi-node trees and what could be the class diagram of this multi-tree, nodes, right? And then, so for this video, I would like to discuss about specific tasks, right? So just to get warm up, and in this pyramid scheme, this project, and we have multi-tree node, and we have a linked tree node, and these two, the tree ADT and the multi-tree node, which stay in the different packaging, right? And then so here we actually put in the DS library. And in this part, which is in the packaging, we want you to take a look and implement. And for multi-tree node, we already discussed it consists of reference, hold the data, and also consists of the array list, child array list, with hold the reference for every child node. And since this part is quite tedious and quite routine based, and such that we just provided that. In this assignment, we would like you to implement the add child, add children, and also the countdown and the get root element and the contains. These have 5 methods we would like you to implement. And also, this is in the linked tree.java. And also in pyramid scheme, we want to implement find load chain. And another person has been completely provided to you, and a pyramid scheme simulation and also provided for you. Okay, so in this module, I want to emphasize for each incomplete function. Okay, so first let's take a look. Part 1, finish the linked tree implementation. The linked tree class uses multi-tree node objects to maintain its structure. Every multi-tree node object carries a specific data member as usual. However, instead of having references to the left and right child node, these multi-tree node objects keep a array list of references to all these child multi-tree nodes, which can hold as many children as you add to it. In this way, you can create a hierarchy of nodes. At the top of the hierarchy is the root node, which is kept as the only field in the linked tree node. And the linked tree has method for adding children to specific nodes already in the tree. And finding those specific nodes are utility methods such as content and size. We would like to implement the following method in linked tree.java. And you can see actually reduce the number of functions we wanted to implement. And the first one, get root element. This method returns the element held by root. And add child, this method has two overloading methods corresponding to the same function name but with different parameter list. You will implement both. The first takes a generic T parent and T child, right? So this one is a generic data type, right? Corresponding to in this case, T, you can replace T as the person. In this add child function, and the first takes a generic T parent. The first constructor, here we took two constructors, right? Two methods, the add child method and the second add child method. The first add child method takes a generic T parent and a T child, invokes the existing method, find the node to locate the parent multi-tree node which holds the give element parent, and then invokes another add child method to add the child element into the located parent node. The second overloading method takes multi-tree node parent and a T child element. Right? So the previous one only have the parent object, and here should be parent node. the job is to create a multi-tree node which holds the child element, then call the load on add child method to append this new child node into its children list. So this is corresponding to use a relist function. If the given parent element cannot be found, element not found exception should be thrown. Here we do not care about whether the child element is duplicated with the other sibling child nodes of the same parent nodes. Nothing will be done if the given child node is none, right? And the other two methods we want to implement contains the method would invoke the find load method to determine if the tree contains a t target element. And the countdown the method is a private helper method for the size method. It will use recursion to count the method of loads in the tree. And so now I would like to, this is description of the method we need for you to implement. So I would like to go to the, first I go to the start code, right? This is linked tree. Let's see, can I make it bigger? Good, and we can make it bigger now. Okay, so this is linked tree, and we should implement the tree ADT, and such that all in abstract method in the tree ADT should also be implemented. Or if they do not implement, they need to pass to concrete class to implement, right? And so this is the constructor of linked tree, and in this case, initialize the given the objects as the element in the root node, right? And then so this is one constructor. This is second constructor by giving the tree node and put that as the root node. And so this method we wanted to implement, right? So the get, let me write down here. So the different method we ask you to implement. Okay, so this is the method we wanted to implement. First one, that is the linked tree.java, right? In this one, first we want to check which is the get root element. So we say based on this previous discussion about the constructor method, right? So we say definitely the root, in this case, you need to implement that corresponding to, you need to comment this one out, right? So common out. So we need to comment out throw new unsupported, right? So here I just ignore that, okay? And also here I would like to okay, I think I put it the wrong place. Okay, good, right? And then the second one, it is you need to implement, which is the return, right? In this method, you need to return root. That's right. So this is the first method we want you to implement. And the second method, so now I wanted to scroll down. Okay, and the second method we want to implement, which is the add child method. And we have two add child method, right? And so both you need to comment out throw something, right? And also to add a child method, we have two child methods. One, it is the given the parent object and also the child object. This corresponding to find the parent and then insert the child load, which hold the child element, right? So in that case, in this one, so we would like to first to find the object, so corresponding to this method. And in the description, we see this method is complete, right? So corresponding to, let's say, the code, right? I used this one to represent the code here, right? Just like here, it's the code, right? Okay, so in this one, first we need to retrieve the root node. So we have to define the multi-tree node. And this multi-tree node, which is a holder for the person. And this is the, I don't want you call as the root. So you can call it as the parent node, right? I use P, parent node. It's okay. So we wanted to find this parent node first. So you have to invoke this method and find the node and give the parent as the input. Can you see? And then after you do this one, then you can add the nodes, add the child. And by given this is the parenthesis, by given P node, and also give what you have the child element here, right? So that's it. So then we have another method. Still is called add child, right? And add child, this is the overloading method, and corresponding to you have the same function, but they have different parameter list. We said how to make sure the function is unique, and we said it's based on the signature of the function. And the signature function consists of function name and the parameter list, right? So corresponding to if the function name is the same, and doesn't mean the two function is duplicated. And we say it's okay, you have the same function name, but the parameter list, if it's different, is fine, right? Then in this one, same as before, comment out. And comment out what we have the throw, right? And then so after that, it is, so since we already have parent loads, we just need to insert these child loads, right? So you can use the multi-tree load, and the same thing here. So if they use T, you also use T, right? Okay, keep in mind. So this one, I think that'll be good. If they use T, you use T, right? Because the T will be replaced. It's okay? Okay, good. So this is a T, and you want to create a child load, right? And the child load is equal to new multi-tree node, and which is a holder for child objects, right? And then in this case you finish it, and then after that it is you want to insert this guy to parent loads. It's clear? Let's see. Okay, and then so we said if what you have this parent loads, right? If this parent loads is equal to long, then in that case, or let's say here, right? I think it will be better we put this one before that. So I want to select and Hold on. You move here, right? And also, let's say erase this one, right? And then so you say if this one equal to none, or the child equal to none. If both are equal to none, either one equal to none, you just return because it makes no sense, right? Okay, and then so after that it is you can add a child. Then add a child. You can invoke this one by, let's see. You can invoke this one by parent node. Dot get children. Dot add. Okay, hold on, right? So this definitely should be get children, right? It's the method. You get a linked list. And you add what? You add this C node. This would be fine. Then you can return. Okay? Good. So this is for this guy. And then so after that, it is we want to implement the contains. And for contains, this is we check the contains, right? And we want to return boolean. And this is the contain T target. So let me move it a little bit. So let's erase this one. It's not nice writing this way, right? Okay, and then so this is the boolean here. Good. So this we wanted to implement for this one, and the same as before, you comma out, throw, right? And then after that, so since it's returned boolean, and you can check. And also, we already provided one method, which is a find node, right? Find this one, find the node, the T target. So this contain, you can check this contain if, we see here, right? The code here. And you can return the find node. This is the method you can use. And give this target. If find the nodes is equal to none, and corresponding to not found, right? So this is false, and all else could be true. That's it for this method, right? So of course in this case I just give you the idea. You may need to debug and adjust that. And then so let's take a look at another method. I think we still have one method left, and which is corresponding to countdown. And in this countdown, even for this countdown, we already gave you the code actually. Yeah. So the code already put it there. So you don't need to write it down here. So you just need to read that. So this one corresponding to if node equal to none, if what you give it node equal to none. In that case, you return 0. If they don't have children, right, and that number of children equal to 0, you return 1 because it counts the data it holds. And after that, it is if here you count the sign to be 1, and based on how many children you have, and you recursively invoke this countdown, and then so after that you sign this countdown, aggregate what you calculated. Let's draw some picture to help you understand. So this one corresponding to I use this color to represent that you don't need to code. So this is the countdown, and it will return integer. This is countdown, right? And this is give you a load, the multi-tree node, and this is the hold the any type of object when you specify. And then so this one corresponding to think about the tree, right? So okay, let's say it doesn't matter. Well, this node they give to you. Once they give a node, if this node is none, right? That's the extreme case. If node equal to none, in that case you do nothing. You don't need to do anything, right? Return 0, and nothing should be added, right? And if the load don't get children, and here they have also get number children, right? Number children count how many children they do have. And if this one equal to 0, in this case, I need to return just 1, right? And after that, right? After that, what you do it is, for example, this is the load people give to you, right? So you count how many, you count, this is this load itself plus 1, right? This is 1, and plus this guy, right? How many here, and how many here, and how many here, right? And how many here. So we see this is the tree consists of root load and sub-trees rooted by the child load of this root load, right? And such that, let me write down the recursive function. So we say count down load is equal to different cases, right? It's 0 if load equal to none, right? 1 if no children. If no children in node, right? And or corresponding to 1 plus summation of count down, which is corresponding to all the children's, right? Let's use this child. We use a child load as example. So child is in nodes. Let's write in this way. Okay, I want to make it a little less, so I have to erase. Okay, so this is in nodes get children. Okay, so this is this one, right? This also corresponding to the code you have here, the code you have here, right? So this is just the mathematical formulation, and so and help you to understand and what corresponding to this recursion here, right? Okay, then in that case we finished this part, and then so you can go back to the problem description and check what it is the second part 2. And the part 2 we ask you part 2, right? And the part 2 we ask you to do it is let's see. Yeah, and part 2, this project comes with a linked tree test file. Some of tests are empty, need to be implemented by you. Keep in mind you need to demonstrate 80% of coverage with your test case. And the provided test get you part of the way there. Complete the following test. So you have to test these methods. Okay, and so once you are done with this test, you should be able to run the test, ensure your linked tree method are working. Then do this before move on to the part 3. And part 3 is the finish PyramidScheme implementation. The PyramidScheme class extends linked tree person. meaning that it has access to all the functionality of a normal linked tree, except it only holds person element. This is because the pyramid scheme has its own methods and overrides some of the superclass methods that contain logical specifically meant for the person class. The person class is a basic representation of a person as an object with fields for a person's name and data balance. So the person class do have two data members. Right? And then so okay, take a look, right? And then so this method you need to implement in pyramid schema is find load chain. This method will use recursion to find a target node and then return a array list to every node above the target node, up to the node that was initially passed in. Essentially, you can think of this as returning an array list of the target's parent, then the grandparent, then the great-grandparents. The who benefits method calls this method in order to get a list of every node containing a person who benefited from money made by the target. This will be complex recursive method. However, the logic is similar to the find node in the linked tree class. So you should use them to help determine the logic for this. This is the hardest part of this assignment, right? So let's go to here and take a look at the code and to say how we can implement that. Okay, that's good. And also I want to go to this one and take a look. Okay, and then so go back to this pyramid schema and let's make it bigger. Okay, so it implement linked tree and then so this constructor, right? Constructor corresponding to initialize the linked tree and also specify some constant. For example, recruit price is $25, paid up corresponding 10%. And also to have another constructor, you can initialize who it is the starting person, right? And also what is the recruit price and what is the percentage, what is the paid up percentage. And so if people give to you, it is the paid up greater than 1. In that case, finally, you want to convert the percentage into decimals, right? And this is the third constructor. This constructor it's just a parameter, it's different, right? This is the initialize the linked tree with the parent object, root object. This is root with root node, and this is the fourth constructor. Okay? You can quickly go through that. And this method, who benefits, this method will invoke the find node chain. In that case, we would like you to return the tree node, multi-tree node as person. And so the person, this is the variable, is a sucker, right? So this is the root node tree, root node chain. And then so one more time, let's go to the root node chain. This is the only method lived in this class. And all another one, which is corresponding to how we handle with this. And this pay up, if you have more time, you can go back here and take a look, right? And this one corresponding to who got the recruited, and he need to pay money to the parent loads and the parent great parent loads, right? And so the money made. And so this one, first you use who benefit to get the owned, and if this is long, you return and just for the on is long and on is empty and get paid all, right? Person at the top get paid all. Money make get element and just balance was for the money made. Good. And then so initialize the money maker gets paid with a portion noted to rows above. And so this one is not require you to write the code, but they'll be good you take a quick look. Okay. So since this laptop seems very soon out of power, I'm trying to make it fast. And this is a collapse method. And if you have chance, you can take a look to what does mean collapse, right? So this is check the old children and it's collapse all the children and then so okay, so you can take a look at this one later. So for now, I want to emphasize the find load chain, right? So this is the find load chain from the root node to the node you mentioned. This is the find load chain. And also corresponding to what? Corresponding to from the root node, you wanted to check for each, let me draw here, right? Okay. So this is another one, which is corresponding to okay. So this is we talk about the PyramidScheme to the Java. And here we have only one function left for you to implement, which is the find node chain, right? And here we give you this boolean, return boolean, right? And so we give you multi-tree node. This is the person, and this is a node. And we also want to say, because you want to find so the another one, it is the person, which is target. Okay, and so in this method, I want to draw a picture, right? So this is the recruit hierarchy structure, right? For example, I just briefly draw it this way, right? So let's just say this is the node you mentioned, the source node, and you want to find out, this guy, right? This is target. This is target. You want to find out the specific path from here to here, right? You want to find the load chain. You want to find this upper chain, right? From here to here. Can you see? Okay, good. So now, how can we find this one? One of the things, just like to find the nodes, right? So the difference is we have to remember who it is this upper chain, and such that in this method, and we claim the upstream, and we also claim the stack. Why? The reason it is, if you go here and you didn't find this target, you want to trace back. When you trace back, then you can continue to check and who is the upstream, right? So these have two specific structure we want to use. One is used to this upstream is used to remember who is above this guy, and then we also have the stack to tell when we trace this tree structure and what we want to save. And then so you use this find load chain. In this case, we have input, right? The stack as the input. So if the stack is return 0, right? In that case, nothing to do. If it's not include 0, so it means you can save what you have to this upstream list, and then return this upstream list, right? So corresponding to, we use this stack. And let's say what corresponding to this is quite similar to the DFS tree traversal. So this is very similar to, I'll use this color, the DFS corresponding to depth first search. And it's corresponding to, let's give an example, right? So when we look at, when we wait the load, let's use the stack. So this is load 1, 2, 3, 4, right? And 5, 6, 7, 8, 9, and 10, 11, 12, and 13, right? So when you look at the load 1, you have load 1, put in the, I use N1 to represent this load, right? I use N and with the index represent this node. And then so when you search to node 2, in that case you deep down, right? Because you don't know if this target which exists in this subtree or not. Can we use the find load? No, we cannot use it, right? And because we need to keep in mind, we need to track what is the parent load. So we have to change that find load procedure. And then so you put the N2 here, then you continually check for N3, because once they have a child load, and if that is not equal to the target, you continue to do, right? So you push and push. And then you find that N3, this node N3 is N5, right? N5, because the child load. You go to here, right? You go to here and go to here. Then you find out, no, this one definitely, no, this target exists. So you pop off. And when you pop off, so I want to draw a little bit longer one. So when you pop it off, so in the way, it's gone, right? And once it's gone, let's use a different color to represent this, it's gone, right? And then so after that is a push, the web continue to push, right? It push, how did you push? So since you pop off, N file, and then after that it is, you check, when you pop off, you go to the N back to here, right? When you go back here, you continue to check the next guy, and you have a N6 here, right? And then when the 6 doesn't work, and then you put pop up. And then so after that it is you go back, and then continue go to this side. So you have N7 push here, right? So let's just say I'm trying to make this one easy. I'm trying to make this one easy, and such that I ignored this one, right? I'll make it smaller. Now I make it smaller now, right? And even smaller now. I wanted to make even this one smaller. Okay, we even make this one small, right? And then so after that it is, if this is only the thing we have, and see, 7, since this is 7, and N7 is leaf load, right? It's not equal to target, and then you will trace back, and then in that case, the N2, because N2 no way to go, right? The N2 is not good. and such that N2 will be pop off. N2 will be pop off, right? And once the N2 pop off, it will continue. It will push N4 here, right? And N4 will push here because you go back here. And then you continue to check because they have still have the child nodes. Then you push what? Push the N13 here. It's N4, right? And then you find out N13 exactly which it is the target. If it is target, in that case, so this is what they exactly exist, right? And so in that case, it means you even don't need to push that. So once you pick it up, you check. And once you check if it's not equal to, you try to explore deeper and deeper. If that's not go, and then you trace back, right? And then so this is the stack we have for now. And then after that, since this method require we need to give the array list. So we convert this one to be array list. And when we pop off, we want to get it is an upper chain, right? Upper chain corresponding to, you want to tell who is the first beneficiary, right? Who is the first guy benefit from the recruited target? And it's N4, and then you have an N1, right? So in that case, in this tree structure, so what we have, which is the N4 and N1, will be the fellow people who got benefit from recruiting the target. This N13, right? Okay, I think this is the general procedure for this find node chain function. And then so I would like to also demonstrate to you, right? And then in this find chain, you can see here, right? And you give the node stack as input compared to the previous method. You have node, you have target, and you have the stack, right? And if the target is long, the load is long, we return false. They make no sense, right? You continue. Then continue doesn't make sense. And load the get element equal to target or not. If it's equal to target, so in that case, you found it, right? And when you found it, corresponding to all the elements, all the load in your stack, which is writing corresponding to the upper chain. And then if it's not equal to the target, then we go to the here. If it's not equal to target. And so in that case, since this node the load doesn't include the element target, and they will push this node into the stack and continue to check if the child nodes, which is include this target, right? So this reason for each child node is also corresponding to the tree structure. Usually we check, right? We say this is a node. And then so we want to check if this node stayed here. You check this node, does it include the target? And if it's not included target, then you want to check the child nodes, the child subtree, right? Child subtree. So this is corresponding to, so what we have this for loop function. And then so here, if they return, you found it return, right? If everything here not found it, so in that case you want to move to the upper level. So it's a stack pop off because you tell this node what they the subtree rooted by this node, which is doesn't help to find the target. You pop it out. This one pop it out. Okay, I think that's all for this discussion. And the only thing left in this question, something very interesting which corresponded to collapse function and also the pay up function. If you take a look, if you have more questions, let me know.